Hi everyone, this is Mert Yeter and welcome to Global Azure Virtual 2020 and my session Containers on the Cloud. Today we are going to talk about Azure Container Services, but from a developer's perspective. Let me introduce myself. I have 15 years of development experience. I am skilled in .NET, C#, Docker, and Microsoft Azure. I also have a master's degree focused on Linux. I am working as a cloud development manager. I am also software section lead, writer, and speaker at a technical community called MS How To. I am also a traffic ambassador. Let's start with the history of application deployments. At the beginning, we have been using physical servers. We install an operating system on it, install necessary libraries, applications like IS, and deploy our own applications on the top of them. This is okay until you need to scale the application you have deployed. You can scale it vertically, so you can add more horsepower to the server. But what happens if the application or the whole operating system crashed? End user cannot use your application until you fix the issue, or basically I can say restart server. How about horizontal scaling? I can add more than one server and create a cluster, which means I have load balancing and a fault tolerance system. But this time it costs too much, and it causes a bigger problem than money: maintenance. When virtualization technology has been discovered, we thought that it will fix all of our problems. Yes, we can scale it easily, both horizontal and vertical, install multiple operating systems side by side running on a hypervisor. As we are only using the guest operating systems for deployments, it has easier maintenance, so we can easily clone the VM, replicate as much as we want. But still, we have some problems. We still need to maintain an operating system, install patches or upgrades that might affect our applications deployed. Everyone knows a typical developer response when something is broken on production or the test environment. It works on my machine. Development machine and the servers are different machines and have different system environments, so there might be missing dependencies or hard-coded paths in your code. Here comes the containers. When using container technology, all the environments are same because your containers run on the same container runtime, both development and production. We have now containers, although all our problems were fixed. But we have new problems. We have some questions like where should I securely store my containers, or how should I use multiple containers at the same time? What about load balancing, or do we have a fault-tolerant design? Of course, there are lots of different options to use for our container needs. We can find all of them in one place. Let's have a look at the Azure portal. If you select the container section in Azure portal, you can see a container registry to store your containers, a container instance to run or test a single instance, a managed Kubernetes service to orchestrate them, or a web app service to use a custom Docker image to run your web app on an application stack. Also, you can find other services under the compute section: Kubernetes service I have mentioned before, and a service fabric cluster to develop microservices and orchestrate containers on Windows or Linux. Let's have a look at some of these services closely. The default option for storing Docker containers is Docker Hub. It is very popular among developers because of it is very easy to use and lots of integration options. But it has limited features in comparison to the others. Another option is you can also deploy a local container registry if you want to do the whole maintenance stuff by yourself. Azure Container Registry is the best option for you if you are using other Azure services or you are not, because it has lots of features. Let's have a look. First, let's start with the security. Azure Container Service supports Azure Active Directory Authentication, role-based access control, Docker Content Trust, firewall and virtual network integration. You can use webhooks to trigger events, when certain actions take place in one of your registry repositories. There is also an encryption option that you can encrypt your images and other artifacts when they are pushed to your registry, and they are automatically decrypted when you pull them back. System or user assigned managed identity enables Azure resources to authenticate the cloud services without storing credentials in your code. You can use private endpoints to privately connect to a service or resource. With georeplication feature, you can synchronize an artifact across all replicas by pushing it to any one replica. Please consider that encryption, identity, and the private endpoint connections are now in preview. How can I manage my containers? If one or more containers are running locally, I can easily say it works on my machine. But what about production? If I need to run 100 or 1,000 of containers, we need to manage them all. As I mentioned on my previous slide, we need to load balance and create a fault-tolerant system. Here comes the container orchestration, and that means another problem for us: implementing and maintaining the orchestration system. Let's have a look at the Kubernetes, a well-known container orchestration tool. Containers are running in pods on Kubernetes. Pods contains one or more containers which are tightly coupled. On the right side, we can see the nodes. A node contains pods which contains one or more application containers which are relatively tightly coupled. Kubeproxy is basically a network proxy that runs on each node, and kubelet is an agent make sure that containers are running in a pod. And there's a container runtime to run containers such as Docker or Rugged. On the left side, you can see the control plane, which we can call as master. Let's have a look at the control plane components. Kube API server exposes the Kubernetes API. It is the front end for the Kubernetes control plane. Kube scheduler watches for newly created pods and selects a node for them to run on. etcd is a highly available key value store used as Kubernetes backing store for all cluster data. Kube Controller Manager runs controller processes such as node controller, replication controller, endpoints controller, and service account and token controllers. Cloud Controller Manager is for the interaction with the cloud providers. Yes, there are lots of components. If you want to deploy a Kubernetes cluster, you need to know each one of them very well. So if there is a problem, you can easily identify it. As a developer, I think you don't need to know so much details. It's a different profession. Why did I tell you these details? Let's go to the next slide. As Azure Kubernetes Service is a managed Kubernetes instance, Azure manages all the control plane stuff, so you are only responsible for the nodes. Let's have a look at what we need to create an AKS. After the basic inputs like cluster name, resource group, and node size, let's focus on other parameters. Under the scale settings, there are two options: virtual nodes and VM scale sets. Virtual nodes allow scaling backed by serverless Azure container instances. Please consider that this feature is not available on the UK data centers yet. And the other one is VM scale sets. These are used for auto-scaling and multiple node pools. Next one is authentication. Under the authentication, you can see there are two options. First one is service principal. Service principal is an identity for use with services to access Azure resources. And the other one is role-based access control. Role-based access control is used for control access to the resources. And the next one is the networking option. We will set some networking stuff here. There's a private cluster option to set the network traffic between the API server and node pools on a private network. The other one is HTTP application routing. It is used for accessing applications that are deployed to your cluster by creating DNS names for application endpoints. Please do not use it for production. You can use it for development purposes. And the other option is the load balancer. You can see it's selected as standard, which means using the Azure load balancer. And the last option is the network configuration. You can paste this with the basic options, or if you want to do the advanced settings, you can select the advanced options. And this is my favorite feature. I think this is the best feature for developers. Azure Dev Spaces. With Azure Dev Spaces, you can test and debug your code end to end and share a development cluster between your team members. This allows developers to run their own version of a service while reusing dependent services. Azure Dev Spaces is not supported on all regions, but if you are using on a supported region, you can use it with Visual Studio Code with the Azure Dev Spaces extension or Visual Studio 2019 with the Azure Development Workload. That's enough for the slides and time for a demo. Let's start with a .NET Core Web application. .NET New MVC. And I will open Visual Studio Code. You can see my source code files on the left. And it is asking me to add required assets to build and debug. And I'll say yes. Before we start, let me show you my extensions. I have installed Azure Account for sign-in and subscription management. Also Azure Dev Spaces, Azure Kubernetes Service, and Docker, and also Kubernetes extensions from Microsoft. The YAML extension comes with the Kubernetes extension, so you don't need to install it separately. So I am going to Dockerize my application. I will need a Docker file. I can create it manually, but I am going to do it with the extension support. I'm pressing Ctrl+P and select Add Docker Files to Workspace. It's asking me my application platform, and I'll select ASP.NET Core. My operating system is Linux. I don't need any other Docker Compose files, and I'll leave the ports by default. Now my Docker file is ready, and I am going to right-click my file, and there's an option here, Build Image in Azure. Now I'm going to click this one, and asking for a name. I am going to name is MS Auto App version 1. Select my subscription. Select my registry. I have already created the registry on Azure Portal. Select image-based OS as Linux. I was logged into my Azure Container Registry. Link to base image. Now it is pushing my container image to Azure Container Registry. Yes, it's completed. Let's check it on my extension. There's a registry section here. Select my subscription. This is my content registry. And I can see my repository and my content image. As you can see, my Docker desktop is not running, and all of this stuff is completed on Azure. So I am going to right click this one, and there is an option to deploy image to Azure App Service. Now I'm going to click this. It's again asking my subscription to use and a global unique name for my web app. I'll choose my current resource group, create a new app service plan, and name it as Minnesota web app. And I can choose free tier on my current data center. Now it's creating app service plan. And now it's creating my web application. It's complete, and it is asking me if I want to open the site. Let's check that on Azure portal. This is my resource group page, and I refresh. It's still creating. Let's create my app service plan, app service, and content registry webhook. Let's wait a bit longer. Yes, now it's working on the web service. Go back to code. And let's do some modifications. Index. And I am gonna add a new text here. I'm going to build a new image. Again, I am going to build image in Azure. This time it's version 2. Select my subscription and my registry, base OS, now it's creating. Just still building the container image. Now pushing image to my Azure Container Registry. Now it's completed. Let's check it again on my extension. I can see version 2. So this time I am going to on Azure portal and my app service. Under the settings section, you can see the container settings. And you can see my registry image and my tag as version 1. Now I'm going to change it to version 2 and save my changes. Let's check my application. As you can see, it is very easy and very quick to change containers in a web application. Let's continue with the Kubernetes service. Now I am going to add my current Kubernetes cluster. You can see the option to create a new one, but I am going to add my existing cluster. I am asking my cluster type, and before I continue, I need to run this command to merge my credentials to my kubeconfig file. And this is my resource group name, and this is my cluster name. Now it's merged, and I'll continue. Now I choose my subscription. It found my current cluster, and I am going to add this one. Now it's edit. You can see namespaces, nodes, workloads, and other stuff related to my cluster. I'm going back to my code. Now I'm going to deploy my application to my AKS cluster, and I need a deployment file. Let's create it. Deployment YAML. Our name is MS Auto App, and my image is MS Auto. This is my Azure Container Registry name, and my container one. And I'll set my ports. And before we continue, I need to run another command. As my AKS cluster has no integration with my Azure Container Registry, it needs to integrate to pull this image from my registry. So I am going to run this command and attach my container registry to my AKS cluster. It takes some time to complete. And I am only deploy my container, and I'm not going to deploy a service. Yes, it's completed now. Let's make this deployment and press Ctrl Shift P again and select Kubernetes apply. Now find the resource. So this is create a new resource, and I click create. It's now created. Let's check it on my Kubernetes extension. I will refresh and see under the workloads and deployments. I can see my deployment here. Let's check pods. And my pod is ready. As I said, I didn't create the service, so I need to port forward to see my application. Right click to my pod, and there's a port forward option. Select this. It's asking me for port mappings. I click enter. And it has run the kubectl port forward command. Let's open the browser and type localhost. You can see the application running on my Kubernetes pod. Let's go back to my codes. I am going to delete this one. And stop. And my deployment is deleted. And the pod is terminating now. Okay, let's have a play with Azure Dev Spaces. Now I am going to deploy my application to a AKS cluster with Azure Dev Spaces. For this, I need to add some configuration files. You can see here Azure Dev Spaces prefer configuration files for Azure Dev Spaces. And I am going to expose endpoints. Yes. Now it's creating Helm charts. And let me show you on Azure portal. Under the settings section, you can see the Dev Spaces. It comes disabled by default. You can enable it on Azure portal, but I am going to do it on PowerShell. Let's go back to my Visual Studio Code. And the configuration file is done. I'm going to run this command to update my AKS cluster to use Dev Spaces. I hit enter. Yes. Now it's creating and selecting Azure Dev Spaces controller on my AKS cluster. Until it finishes, let's set a breakpoint on my home controller. So I have already set it here. and we are still waiting to complete. This allows me to use the space, and I am going to select the default one. And there's a warning. I say yes. And it's now config and select default space. It's now complete. So I am going to run section and select Azure Dev Spaces profile and hit the run button to start debugging. Now it's installing Helm chart and building the container image. Now it's waiting for container. Now it is ready. You can see a URL here. This is my AKS cluster. Now I click this one and I can hit my breakpoint. So I press continue. Open it. Now you can see my application running on my AKS, and I can debug it directly on my AKS cluster. Thanks for watching. If you have further questions for me, please do not hesitate to contact me. You can find my contact information, my mail address, my Twitter, LinkedIn, and GitHub. You can also send questions to our community MS How To. Thank you very much and stay safe.